Welcome to the Digit Design It video tutorial. I'm Amy Tabret, and in this video I'll be showing you how to use Digit Design It to plan a subsurface testing program and predict its performance at detecting sites. To start with, I'll be showing you how to create a digital analogue of your survey area within Digit Design It. Then I'll be demonstrating how to use the input tools to design an optimal test unit layout. After that, we'll run some simulations using this layout and export their results. I'll also show you how to use Digit Design It to investigate how effective your chosen grid is likely to be when detecting sites of different sizes or artifact densities. We'll look at the range of options provided for exporting useful information and images from Digit Design It, and I'll finish up by showing how simple it is to open your exported text file results in Microsoft Excel. If you would like more information regarding the things discussed in this video, please check out the paper shown on screen, and if you use the Digit Design It tool in your work, please cite this paper. Once you've downloaded the Digit Design It model from our website, this is what you'll see when you first open it up in NetLogo. Don't panic if it looks a bit busy. We can break the display up into 4 parts. So first we've got this green and purple region on the left, which is where you'll input your model parameters and run your simulations from. In the center, we have some summary statistics which will be automatically generated for you as the simulations run. And on the right, we've got the blank black world where your survey area will be created and where the simulations will run. And at the top here, we've got the grey toolbar provided by NetLogo, which allows you to control the speed that your simulations run at by dragging the slider. The first step is to input the size of your survey area. For now, Digit Design It only allows area inputs which are square or rectangular. So I'm going to enter a survey area width of 110 and a length of 125. So the width will appear on the horizontal dimension of the black panel and the length will be the vertical dimension. So it's important to turn off this switch, which is site centers inside survey area, because it's much more realistic to allow partial sites to spawn inside your survey area. And then all you need to do is click Set up Survey Area, and there it is. And so this is your survey area inside here with a thin border around the edge. Now we have a digital version of our survey area, we need to input some parameters of the sites you are expecting to find and the size of the pits you're thinking of digging. For the example today, I'll dig test units which are 1 meter long and half a meter wide. So you can see here, you need to select 1 from the drop-down box for test unit length and half for test unit width. Now I'm going to assume that you've read our papers and understand what these next parameters refer to. So this section here is where you need to enter information about the size and density of the sites commonly found in the area and how the artifacts are distributed within those sites. So today I'm going to say the artifacts aren't clustered, so we don't need to worry about the clustering parameter K. We're going to have a site diameter of 20, an average density of 7, a linear density distribution function, and the last thing to think about is whether or not you want to fill the boundary gaps. So what I mean by boundary gaps is an hexagonal layout for sites of this size will produce a grid that looks like this. And you can see there are gaps along some of the transects and in some of the corners. So in order to fill those gaps, if we turn it on and try again, you can see pits are generated which will fill in the gaps and ensure that the grid intersects any sites that are spawned in these regions. We've inputted everything the model needs, so now we can run the simulations. All you need to do is select the number of simulations you'd like to run. So in this case, when I right click and select Edit, I'm going to type 100, but I'd recommend at least 1,000. I'm only choosing 100 now so that we can get through them in a reasonable amount of time for the video. So once we've set that, all you have to do is click. First of all, I'm going to clear the sites and pits, and then click Run Simulation. And there we go. The results of the simulation we've just conducted will appear in the summary statistics in the center of the display. You can see that we had a 90% rate of site intersection and a 79% rate of site detection here. Each time you run the simulation, you'll get slightly different rates of intersection and detection because of the randomization in the model. Running higher numbers of simulations, like 5,000 or even 10,000, will reduce this variation. So the current statistics show one set of possible results from 100 simulation runs using the parameters we inputted here. But what if we wanted to know how well this grid will detect smaller sites, or those with different densities or artifact distribution patterns? So luckily, down in section 4, we can do just that. So for example, we are going to test the current grid with similar sites, but they'll be denser. So I'm going to raise the average density to 10. And what we need to do is set up a new border and then run the new simulation. And you'll see that more dense sites have a higher rate of intersection, but a pretty similar rate of site detection. And that's probably because the increase that I typed in was pretty small. So we can also test to see how well the grid will perform, will detect smaller sites. So for example, we've got 20 here. The grid is set up to detect sites with a diameter of 20 meters. So what if I change that to 15 down here? We'll set up a new border again and run the simulation. And here you can see that the rates of site intersection and detection drop significantly. Step 5 in the model allows you to export some useful things. We're already familiar with the Show Optimal Layout button, which shows your grid layout. To this, you can add a north arrow pointing in any direction. And it's up in this corner. White guy. You can export your grid layout as a PNG file by clicking Export Map as Image. And I'm going to call it video. And make sure you write .png at the end, because NetLogo doesn't automatically put in the file extension. Yes, I do. You can also save the coordinates of each pit if you'd like, to make laying them out on the ground easier. So you can save them just in meters relative to the 00 point in NetLogo, or if you know the location of this point as a georeferenced coordinate, then you can put it in these boxes. Make sure that it's in meters though. So for example, I'm going to put in a location near me, and then we can go save unit coordinates, and I think it will automatically save as a text file. And then if you'd like to save the results of your latest simulation, you can go Save Simulation Results. This will also save the parameters which obtained the simulation results. And that will also save as a text file. Lastly, I'm going to show you what the file we've just exported looks like and how to easily import it into Excel. So what we've got here is I've opened the file that contained the grid parameters and the simulation results. So you can see we've got a long list of the headings, so these are just the things that you've exported, and then the actual results of those follow in the list. So, I have noticed that Excel sometimes won't recognize this file automatically without putting a .txt at the end. So all I'm going to do is rename it where I stored it with an extra file extension .txt and press enter. So now when I go to Excel, I want to go to the Data tab and then click From Text or CSV. And you'll see there our file appears. So we'll select that one and go Import. And then a little window will come up asking how we want to view the data, but you can see it's been very clever already and has worked out how to view it. So that all looks really good. So all I'll do is click Load, and it appears in our Excel spreadsheet. Thanks for taking the time to watch this tutorial. Remember, if you need more information, check out the paper we've written about using this tool, and please cite this paper if you use Digit Design It in your work.